A rectangular plot of land will be fenced into 3 equal portions by 2 dividing fences parallel to 2 sides. The area to be enclosed is 6,000 square meters. Write a function that describes the amount of fencing used on the plot of land. Use a graphing calculator to find the dimensions of the land that require the least amount of fence. So I didn't tell you to find a function in terms of any specific variable. I just wanted you to find a function. But it should be of one variable, since that's what we know how to deal with in this course. So let's draw a picture. We have a rectangular plot of land that will be divided into 3 equal portions by 2 dividing fences parallel to 2 sides. So let me draw in some dividing fences. So how much fence was used, right? Write a function that describes the amount of fencing used on the plot of land. Well, the fencing, let's see, if I were to call this side x and this side y, then I have 1, 2, 3, 4 x's. So I need 4 x's and I need 2 y's. Now let's try and get this down to one variable. So let's start there. We have the amount of fence used is 4 x's and 2 y's. But we're also told that the area to be enclosed is 4,000 square meters. Well, the area is just x times y. And so then we have 4,000 is equal to xy. And what I'm going to do is I'm going to write this, I want to write a function of x. I want the fencing as a function of x, so let me replace the y. So let me solve for y in the constraint. So dividing through by x, I find that y is equal to 4,000 over x. So then f of x would be 4x plus 2 by 4,000 over x. So f of x is equal to 4x plus 8,000 over x. You could have also answered this in terms of y, and you would get a similar looking function. It would be but it would be slightly different. In the end, you'd get the same answer. All right, so now let's go to the calculator, and our function is 4x plus 8,000 over x. A window, again, the window settings are a little tricky at this point, but we know the minimum value of x is 0. The maximum value of x, I'm just going to sort of guess and say the maximum value of x is 50. We use a scale of 5s. The y here is the total amount of fencing used. So I'm going to go 0. How about 200? And I'll use a scale of 10s there. Scale isn't the most important thing here. We're more worried about minimum and maximum. And if this doesn't work, then you can change your settings again. So let's see if we get a graph in those settings. All right, I didn't get anything here. So I'm going to go ahead and zoom out a little bit. I'm going to change my y. I'm kind of thinking that my y is probably the problem here. So let me go to 1,000 on the y's, and I'll change my scale to 100. Let's see if that helps. All right, that's a little better. It seems to be decreasing. Now, since they tell us to look for a minimum, I should expect that to increase again. So let me go ahead and change my window again, and let me increase my x maximum to 100 now, and see if that helps. And now I clearly see the function decreasing, and then it begins to increase. Let me find that y minimum, or that minimum right there. So let me calculate the minimum. All right, make sure you go left of where you think it is, and go to the right past where you think it is, and then go back towards the middle, and hit enter a third time. So the x minimum is 44.7. So the x value that produces the minimum is 44.7 meters. We're asked to find the dimensions of the land, so we need to find the y value. Well, the y value is 4,000 over x, so that would be 4,000 over 44.7. $89.5. So the dimensions that require the least fence fencing are 44.7 meters by 89.5 meters.